then too bad lah. You're supposed to be paying attention in class also. Okay, come. Question 1. Find the equation of circle passing through the points 2, 6, -2, -2, center lying on the line y equals to x plus 1. So can you imagine the circle? So a quick sketch will give us this. Y equals to x plus 1 is a line sloping up like this, intercept 1. So y equals to x plus 1. The center is somewhere here. Then I've got 2 points given to me, 2, 6. So if this is 1, this is 2. 6 is, okay, not enough space. Let's say 6 is here. A, 2, 6. And I've got another point, -2, -2. So -2, -2. I need to be able to draw a circle that covers, that passes through point A, point B, and the center is somewhere on my diagonal line. Okay, this one doesn't really look like it, right? Because the center not on the diagonal line. So we just adjust. Let's just adjust until we get something like it. Okay, this one. Is the center somewhere on the diagonal line? Kind of lah. It's just a sketch only. And then it passes through point A and point B. Okay, this is the sketch. So how do I create or find the equation of such a circle? What are some of the things that you have learned so far? Which is not a lot. You haven't learned much anyway. So what are some things that you have learned? Midpoint. So do you think midpoint is useful over here? Why? Wait. Are you saying that the midpoint will be the center of the circle? Midpoint of AB? Is that it? Is that what you're saying? Is there an assumption you are making when you think that AB is the center of AB is the center? What is the assumption you are making? You are assuming that AB is the diameter. Therefore, the center is your midpoint. The midpoint is the center of the circle, right? But did they say that AB is the diameter? No, they didn't. So you cannot make that assumption. So it doesn't help over there. What else do you know about circles? Huh? Yes, radius is the same, but I don't know where the center is. Come on, what have I taught you about circles for this topic? Not just the. What about the circumference? Okay, the circumference is from the center to. Okay, the circumference can be described by center of the circle with a radius, and then you draw an arc around here. We get a circle, right? Okay, so what is the equation of such a circumference, of such a diagram? What is the equation given by? What would you write as the equation of a circle? X squared plus y squared equals to? Are you sure? X squared? X squared plus y squared plus gx, is it? Do you usually write gx or 2gx? 2gx. Or 2gx, okay. 2gx plus 2fy plus c. Is it usually a plus c? Or plus c then equals to 0, right? This is the equation of a circle. If you are able to find, for example, the center of the circle, you'll be able to get g, you'll be able to get f. Right. But there is another formula for the circle, right? What is the other formula? What is the other formula? What do we call it? Standard form, is it? Yeah, standard form. First, we need to define some items. Okay? Let's have the center called. What would you like the center point to be called? Huh? Give me letters to represent the center of the circle. No, not E. We shouldn't use E. Okay, can we just use A and B? A, B, okay. A, B. Okay, so far? Now I want an equation to describe this circle. Means this equation will be able to give me any point on the circle, right? Any of these points, it will have x and y coordinates. And I want to be able to use this equation to describe these points, right? So let me just have a general point. Let's call it x and y. Understand so far? I want to come up with an equation linking x and y. It has got to be related to the center of the circle. It has got to be related to the radius of the circle. Okay, and the standard form will be x minus a square plus y minus b square equals to radius square, right? Okay, now from here, what next can we do? You cannot solve, right? Then how? Is there something you haven't used yet? Y equals to x plus 1. Okay, what can we do over here? Sub in what? X minus a square. What do you mean? No, you haven't used this equation yet. How do we use it? What is so special about this line? What's so special about this diagonal line? Intersects a 1, so what? What did the question say? The what?
Center is lying on the line.
The center is lying on the line. What do we say is the center of the circle? A, AB, right? So A can substitute here.
Yes.
B can substitute here.
Yes.
How many equations do you have now? Altogether, how many equations? You have 2 equations from here, right? Then you have 1 equation from here, isn't it? So you have 3 equations. Aiyo. Okay, from the red color arrows, how many equations do you get? 2 equations with how many unknowns? 3 unknowns. Your A, B, and R. Alright? Now, I have a third equation over here. All I need to do is sub A inside this X. I sub B inside the Y. I get a third equation, right? 3 equations. How many unknowns altogether? 3 unknowns. You can solve. Why you look so surprised? Let me show you. So step by step. First equation, we wanted to substitute 2 minus 6, 2 minus a. 2 minus a square plus 6 minus b square equals to r square. That's my first equation. Second equation, negative 2 minus a square plus negative 2 minus b square equals to r square. The third equation is y. So that's b equals to a plus 1. So you see 3 equations with 3 unknowns, a, b, and r. Confirm can solve. Okay, so let's talk about these equations over here. So it is the same simultaneous equation, but now we have 3. 1, 2, and 3. Which one do you want to start with first?
You start 1 and 2 together.
1 and 2 together, because both of them give us r square, right? So we have 2 minus a square plus 6 minus b square equals to negative 2 minus a square plus negative 2 minus b square, right? This is my third equation. Oh no, this is my fourth equation. Yeah, then sub 3 into 4. So all your b's will become a plus 1. So now your equation 4 left only with 1 unknown. Alright? Then with 1 unknown, you can substitute into equation number 3 again. Then you get both a and b already. Once you get both a and b, you can substitute into 1 or 2 again to get r. Then you have the answer already. Understand? So you must make use of all the information that's given to you. I don't want to waste time doing the answer for you. So just know the process, good enough already. The rest is just your own practice. Okay, so let's talk about question 2. Practice now 5. Question 2, part 1. How will you do this question? Read the question. Read. Line, cuts, circle, 2 points. Meaning, line, intersect, circle. What do we do to find A and B? Simultaneous equation, yes. So we have x squared plus y squared equals to 10. Just very quickly, can you tell me what's the radius of this circle? What is it? How can the radius be 0? How do you get radius negative? What is the radius here? Yes, square root 10. What is the center of the circle? 0, 0, yes. So this is my equation number 1. Equation number 2 is that y equals to 2x plus 5. It cuts the circle at 2 points. How many answers do you think you will get? How many different x do you think you will get?
2.
Obviously 2. They say cut 2 points, right? So we can do a sketch again. So I have a circle, x and y. Center is 0, the origin. This must be square root 10, right? Because the radius is square root 10, so this must be square root 10, square root 10, square root 10 with a negative. Okay? Rough calculation, how much is square root 10? Roughly how much? 3 point something, because square root 9 is 3, right? Square root 10 must be 3 point something. Now, what does this line look like? Horizontal, vertical, or diagonal?
Diagonal.
Sloping up or down?
Up.
Passing through y-intercept of?
5.
So it's above, right?
But starting to
Okay, so this being 3, maybe somewhere here is 5 lah. Can? Now I need a diagonal line passing through this point, and it cuts the circle at 2 points. There are many ways to cut it, but this is already a fixed equation. You need 2 points in order to sketch a line, right? What is the x-intercept? That means when y equals 0, what is x?
2.5.
No? When y equals 0, what is x? Negative 2.5. Is that bigger or smaller than negative 3? So it's this side, right? Somewhere here lah. Negative 2.5. Okay, so my graph looks like this. Okay, I cheat a bit. This is my negative 2.5. Get it? So it intersects at 2 points over here, 1, and over here another 1. And they call it points A and B. So you do a simultaneous equation, you will get 2 sets of xy coordinates. So you you get x equals to something or something. Then y equals to something or something. You must be able to pair them up. That's why your final answer will be what? You saw something like this? Yeah, you did. When? Parabolas. So we call it A, x, y, and B, another set of values. Okay, class. Next part. Find the equation of the perpendicular bisector of AB. How do I find perpendicular bisector of AB given the coordinates of AB? You found them already. So midpoint is definitely important, right? Midpoint of AB, no problem. Just the average. So let's call this M. What do you do after you get the midpoint? You see, for the equation of a straight line, right, you need either 2 points or 1 point plus gradient. Currently, you only have 1 point, which is point M, the midpoint. So find gradient. How to find gradient? Find the gradient of AB, then you find the gradient of perpendicular line. Because the product is -1, right? Don't go and make the assumption that it passes through 0. Nobody said that. But subsequently you will learn that it actually passes through 0 lah. Next time, okay? Next time you will learn. So a perpendicular line passing through it, because I know it's going to pass through the origin, I draw it this way. But if you don't know, then you don't go and purposely pass through the origin, okay? Just draw a sketch first. Then you will find the equation of the line. What do you think is the y-intercept? Now that I tell you it's going to pass through origin? 0. So it's going to be an equation y equals to negative something x lah. Right, it slows down. That is what we expect to see. Let's check whether I'm correct. This is on chapter 6.2. Y squared equals to kx. Let's start with the easiest form. What is the simplest value of k you would like me to start with? 1, right? No point telling me k equals 0, because you get y squared equals 0. So let's talk about a case where k equals to 1. Example, k equals to 1, so y squared equals to x. What does this graph look like? When we don't know, right, we can always plot x and y. Okay, first, is it going to be a straight line? No. Obviously not. It's not y equals mx plus c. You already can see the diagram in your textbook, but ignore it for a while. I am now teaching you how to sketch the graph if you forget what the shape looks like. Because in 6.3, we have more graphs, which we require you to sketch. If you cannot memorize, you must have a backup plan, right? So this is the backup plan. This is how we can always try to find out. Okay, can x take a value of 0? Yes or no? Yes. When x equals to 0, what is the... Okay, when x is 0, y is... 0. Let's talk about x, y squared, and then after that we get our y value, okay? Since the equation is y squared equals to x. So when x equals 0, y squared equals to 0. Y equals to 0. What happens when x is 1? Okay, let's try 1. So y squared equals to? Y equals to? What happens when x equals to 2? Y squared equals to? X equals to 2. Y squared equals to? Who needs me to explain?
You bracket the y squared.
What do you mean I bracket the y squared?
Y squared.
Yeah, y squared equal to x lah. So when x equals to 2, y squared obviously equal to 2, right? So what is my value of y now? Okay, good. Let's do a few more. 3. So y squared equals to 3. Y equals to 3. Okay, next one, 4. Enough? Do you think you have enough data to plot? Okay, decent, decent. What can x take negative values or not? Let's try lah, negative values. Let's say x equals to negative 1. What is y squared? Possible or not? Can x take negative values? Cannot. X is only positive. And what is the smallest value of x? 0. Okay? No matter what I do for k over here, whether k is... Oh, okay, never mind. I don't want to go there first. So right now, let's try to sketch this. When x is 0, y... x and y. When x is 0, y is 0. Yes? When x is 1, y equals to 1. Okay, another point over here. When x is 2, what is y? Square root 2 is about 1.4, isn't it? So if this is 2, 1.4 is somewhere here. This is my next point. When x equals to 3, 1, okay, so smaller. When x equals to 4, then it is exactly 2. Okay? So now I'm going to join them up. Because that's how you plot the graph, isn't it? Join them up. It is a... No, it is not exponential. It is. It is increasing at a decreasing rate. You are right. What? It starts with P. What is the shape of this graph? It starts with P. Parabola. This is, okay, this is half of a parabola, am I right? Because the parabola is for power 2, isn't it? Do you have power 2 over here? Instead of x squared, you have y squared now, isn't it? But how come my parabola look like halfway only? Then you look at your textbook, how come they have the other half of the parabola?
Because of the K.
No, it's not because of the K. There is something in our table that we missed out. No, K we already assumed to be 1. You see, for this particular graph, right, it is K equals to 1. Therefore, y squared equals to x. Why got negative values of y? Why would there be negative values of y? You see, we start off with when x equals to 0, y squared equals 0, y equal to 0. When x equals to 1, y squared equal to 1. Am I right? But is this the only answer for y? What is the other value for y that will result in y squared equal to 1? So there is an or y equals to, here's 0 lah, negative 1, right? What do we have for the other value of y? Then you can go on negative root 3 and negative 2, am I right? So for the same x value, I get two answers for y. So when x equals to 1, y equals to 1, as well as negative 1. Okay? Then is it going to be a mirror image? Yeah, obviously. So it looks like this. Okay? Now this is my graph of y squared equals to x. How do we relate this to our the parabolas that we have learned in the past? Y equals to ax squared plus bx plus c. Can you see the similarity between this and this? What are some similarities that you can see? There is a square term, right? What we are used to is x squared, but now we are teaching you y squared. So you get the same shape, which is a parabola. But how will you describe this parabola? Is it upwards? It's a parabola opening to the right. So you cannot say smiley face or sad face anymore. That's why you have to use the correct terms. This is a parabola opening to the right. Now, what do you think will happen if x, the value of k changes? Let's say k instead of 1, let's say k is now equal to 10. When k equals to 10, how will my graph change? So this is now equals to y squared equals to 10x. Am I right? So when x is 0, y squared will be 0 still. Okay, this one no change. When x equals to 1, y squared equals to 10. Now this changes. From 1 it became 10. What happened to the y value? Square root 10 and negative square root 10, right? Okay, so this is negative root 10. This is positive 10, positive root 10, and negative root 10. Where is positive root 10 in this side? Above or below? Hey, root 10, no. Above, alright. So it is higher. Root 10 is about 3 point something. So we expect this point to be somewhere here. Alright? Okay, a bit higher. It should be 3 lah. 3 somewhere here. Okay, so something like this. And on the other side, it will be over here. Now with just this point, can you tell me what the shape, how will the shape differ when k equals to 10? It gets it is stretched in the in the y-axis direction, of positive y, negative y direction. Is it clearer if I say that? It is stretched in the positive y and negative y direction? Okay. Desmos will tell you the same thing. Okay, it is stretched. Now, what happens when, let's say k, I change it to become 0.5? How will the original graph of y equals to x, y squared equals to x change when I have a graph of y squared equals to 0.5x? It goes narrower, right? You compress it in the positive x, negative, positive y, negative y direction. So there's a difference between compress and expand. It is dependent on this value of k. Alright? And then, you know our parabola, right? Can open up, can open down. Now you can open to the right. So how do we open to the left? What do you think is the value of k that will result in... Okay, let's try and figure it out. You are saying that k possibly could be negative. So y squared equals to kx still, right? If k equals to, for example, negative, what would you like? Okay, k equals to negative 1. Therefore, y squared equals to negative x. Possible or not? So possible or not? My question is possible or not? Possible? Who thinks it's possible? Raise our hand. Okay, who thinks it's not possible? Raise our hand. Okay, those who think it is not possible, why? No, that's not a good answer. Why do you think x can? Why do you think this is impossible? Huh? Y squared is? So this is positive, right? Then this must also be positive, right? Can this be positive? When x is negative, then you will get positive, isn't it? Where is your x negative in your Cartesian plane? Where is the negative x? Where is negative x found? This side, lor? Then there will not be anything over here. What the graph will therefore look like is this. This is if k is negative. Understand? Let's try some questions. Practice now 6. Part 1.